So, we were talking about that whole thing between tubes and solid state. Like when we got the QX-5 dialed in for the first time, when we had the prototype in there, I'm like, oh, like maybe, just maybe, we might have like actually crossed that threshold between digital and analog. Like, and I'm still not sure. But I mean, it's like, we're closing in on that. It's kind of, it spooked me, because the thing is like, we've got a turntable here, but we don't use it very often, because with digital, it's always consistent. So when you're doing listening tests, you don't have to worry about, well, what's the humidity today, and like, what's my VTA, and did I get the record clean just right, and it's kind of like that whole tubes versus solid state thing.
Mm-hmm.
And so it's like, we've always done our listening tests primarily with digital, and we love, I mean, I've got probably 10,000 LPs, like, I don't want to go buy those again, And so, analog's always been important to us, but like, like I was sitting there when we first got the QX-520 prototype up and running, and we were sitting in the sound room, and I'm just like, is this really that good? Like, I mean, I'm kind of curious. I'd be tempted to like, I mean, because it's gotten to the point where it's like, I'm not going to say it's better than vinyl. I would never say that. It's just like I said, I would never say that the 20 series is better than tubes. If you've got the patience for that, great. And one thing's for sure is that you probably have to have at least a $20,000 to $30,000 turntable. Well, I mean, think about it. So you're talking about a good cartridge starts at 1,000 and goes up to 10 or 15,000, right? A good arm starts at 1,000, goes up to 10 or 15 or 100,000, right? And a good table starts at, 2 to 5 and goes up to 200,000, and then and then you got to have a phono stage. A good phono stage, starts at what, maybe a couple thousand.
Yeah. See, I can't comment on any of this because Mikey Fremer would get mad at me.
Yeah. And so, like, when you look at the whole vinyl front end, with your cartridge, your arm, your table, your phono stage, your interconnects, all that stuff, like, I know that the QX-520 is going to be as good in that sense you're talking about. Like, I'm not going to talk about sound staging or sound depth or like this, what minutia. It's just like sitting down and enjoying that experience. Like, I think you're going to have to spend at least $20,000, if not $50,000, to get that kind of experience that you can get from the QX-520 with digital.
And when we say digital with the QX-520, being that there's so many input choices, is there variation in quality with those input choices?
Absolutely. So, it's like, when it comes to audio, everything makes a difference. And all the stuff that shouldn't make a difference makes a difference. You know what I mean? Like when I was at Avalon, like we offered the speakers with different hardwood finishes. We always used American hardwoods because I'm not going to chop down the rainforest just so someone can have what they think is a nice looking speaker. So, we would have walnut and maple and cherry were the three primary woods we used. You could actually hear slight differences between those woods. And then we, for a while, to do it at a lower price, we painted some with Nextel, which is that special catalyzed paint that is like suede. And that definitely sounded different than the wood veneered ones. You know, so like everything makes a difference, right? Like, so when you talk about, like, think about, like, take USB audio, for example. Does it make a difference if you, your USB cable? Does it make a difference what software you're using? Does it make a difference what your computer is and how much RAM you have? And like, does it make a difference if you have a jitterbug? Does it make a difference if you have a reclocker? Like all these things make, like it's kind of like, right? Like, so everything makes a difference, right? So it's the same thing on the QX-5. You've got all these inputs and there's all these variables that are outside the QX-5. And so, you know, when you listen to some inputs, how it's going to sound. So you've got three main categories of inputs, right? You've got the Ethernet input, you got the USB input, and then you got the SPDIF variants. You know, whether it's Toslink or AES EBU or, you know, 75 ohm, you know, with BNC connectors and you know. So all that stuff, you know, can all make a difference. So with all those different variable inputs, you know, like I said, there's a lot of stuff that's out of control. And what we deliberately try and do is everything we can to minimize those things. So we have, you know, separate power supplies for each input has its own power supply. So then if you have different things connected, it's not going to interfere with something else. When you select inputs, different things get shut down. Like all these crazy things like that. And we try and do everything we can to minimize so that when you hook up, whatever you hook up, we try and make it have as least effect as possible. And you know, and there's only so much we can do. But I think you might be surprised at how far we've been able to take some of that stuff. And a lot of that comes down to for digital, and it's just like everything else in music. I think what it comes down to a lot is timing. And so in digital, really what the timing thing is related to your master clock. And so, you know, we're talking about, you know, it's commonly referred to as jitter. And what's more important to that is to look at the spectral distribution of the jitter. So what frequency is the jitter happening? And so the technical name for that is phase noise. And so you'll see it's actually phase noise at a certain offset from the carrier frequency. It gets kind of technical. And the first people to actually publish an ad for that was when not Pioneer, but TAD came out with their $30,000 CD player. Remember that? Several years ago. And they said, we've got this special crystal, and they showed the phase noise plot, and it shows how much the phase noise was. And they had a really, really good oscillator in there. And so that's why you have a lot of people with outboard clocks and all these things, and you know, you're trying to get the phase noise down really low. Well, it's always best to have that clock as close as possible to the point of conversion, which is the DAC chip itself. Because trying to bring it in there, you know, it's like there's a lot of ways for mischief to occur. So instead of having an outboard clock, what we do is we put that clock in there. And being in Boulder, we're really, really lucky. So what happens, because there's all these crazy smart people that love to live in a beautiful place, And so in Boulder, there's this thing that used to be called the NBS, the National Bureau of Standards, and it's now called NIST, National Institute for Standard and Technology, which has a zillion divisions. And the one here in Boulder is for time and frequency standards. So there was a guy there, and I was riding my bike to work one day, and I met this guy. I saw his office, so I said, slammed on my brakes, and I said, that looks interesting. And I knocked on the door, and I'm saying, like, what do you do? And he says, oh, I started this company, and here's what we do. And I'm like, that's really interesting, because that applies to what we do in audio. And so it turns out this guy named was Samuel Stein. And he had worked his way up the chain at the Boulder branch of it, NBS, was what it was then, until he was the head of all the laboratories. And then they actually promoted him to be the president of the whole thing. And then he said, no, this sucks, because I really want to get back in the lab and do stuff. I don't want to shuffle papers. I don't want to be that guy. So he demoted himself to get back in the lab. And then he invented this thing, which is a way to measure phase noise. And so, like, he'd already done his time and gotten his, retirement and everything. So he left the government with his pension, this everything. He started this company. And then he sold it. It was this fantastic way to measure phase noise that no one had ever thought of, and he came up with it using DSP chips. And so then he sold it and, retired, and then he had, he's well off. So I talked to him for a while, and he was like, oh yeah. And so he's like, so I was saying, so like, when you wanted to get a good crystal, what do you get? He goes, oh, well, the best ones are from Morion. And I'm like, well, what's Morion? So he's like, well, they're this Russian company. And I'm like, really? Like, he's like, yeah. It's like certain countries specialize in certain things, right? Like, like, if you want to get, really good, I don't know, you name a country and they're really good at something, right? Like if you want to get a really good violin, like go to Italy or something, right? Or if you want to get a really good watch, like you go to Switzerland, right? Like certain countries do certain things. Well, it turns out that Russia has been into, like, they're really, really, really good at certain things, and one of the things that they're really, 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 really good at is crystal technology and timing technology. And so he said, the best crystals really are Morion crystals. And so I went, okay, good. So it's just like filed away, because this was before I had my accident when I could ride my bike. This was a long time ago. I filed it away. And so then later on, I was like, okay, we're going to make this thing. So I contacted Morion. I said, look, we're this little crazy company, and we're not going to do much business with you because we're just a small niche company in a small niche market. But we can, once we start using it, like, people will pay attention to what we do, and then they'll start using it, and there's a whole market that you can open up and expand. And they're like, cool, great. And so we made some contacts there at Morion, and they're based in Russia, and they've now opened up an office in the U.S. And these guys, they're like the guys at Room. Like they make their money doing, like, because they make crystals for, like, satellites and things like that. Like, they know how to make their money and stuff. But they also love what they do. And so they're always looking for new things, because they never know, like, where the new next idea is going to come from. And so I said, we want to get a special cut crystal. There's a crystal cut called an SC, which stands for stress compensated. And it has lower phase noise than any other crystal cut. And the difficulty with it is that normally it needs to be in an oven to be at the right temperature for it to work right. And we said, we don't want to have an oven because we don't really care about the frequency stability. It doesn't matter if the music's running, 10 parts per million too fast, like no one's going to notice, right? Like, literally. Like, I don't know if you could even measure that, unless you had like $100,000 worth of test equipment, right? So we don't really care about, but what we want is like really, really low phase noise. And they go, oh, great, that's a great challenge for us. So they worked with us to develop a special modification of an SC cut crystal that has all the performance attributes, but it doesn't need an oven. It works at basically, room temperature or slightly above, because inside of a QX-5 is a little bit above room temperature. It does, And so they made this special crystal for us, and it doesn't need an oven, but it has the performance of an SC cut crystal in terms of the phase noise. And we're able to get the clock that has the performance of like one of these $10,000 or $20,000 outboard clocks. But we're able to get it for much less because we don't need an oven, we don't need an outboard enclosure, we don't need a power supply, we don't need a power supply for the oven, we don't need any of that stuff. And we're able to put it in there and get the performance. It's just, and that's part of the secret of the QX-5 is because the clock is so crazy good, and it's as good as one of these outboard, $5,000 or $10,000 or $20,000 clocks or clock modules or options or whatever. And it's built right in there, and it's like, I'm trying to think how it works now. I think what we did is we have it, it's like within like a centimeter or two of the DAC chip,
So is this something that when you worked with them and when, let's say, a prototype was finally delivered and your first listening impressions, is this something that was one of these wow moments, or?
Well, it was interesting because this is one of the few areas where you can correlate if you know what to measure and how to measure it, and you've got like $100,000 worth of test gear, and you know what you're doing, you can actually make some measurements that actually correlate with sound quality. And then the thing with crystals is that it's really hard to get them to be consistent. It's almost kind of like an LP stylus, right?
Yeah.
Right? Like you can say, okay, like you can get pick a cartridge, right? Like you're not a vinyl guy, but just pick whatever,
A Benz.
Okay, so a Benz, whatever, a Benz, whatever their a Benz. What was their LP was one of their good cartridges a few years back. They had one called the Benz LP, and it had an ebony body and stuff like that and stuff. But you still got this diamond that has to be mounted. It's got to be polished, and they can get that really good. But then you got to mount that to the cantilever, and if there's even a few tenths of a degree of misalignment, that's going to affect that. And so you've got to adjust the whole thing to compensate that. And it's kind of the same way with crystals. To get consistency like that, you have to work with a company that's been doing this for a long time. And like Morion's been making crystals for like 60 or 80 years. And they've been, and they're into it. Like they're crazy about it. And so they can give us a really high quality thing. And so first we sent it off and had it measured and made sure it met our specifications. And we had samples, like we got 10 samples and we measured them. And it takes like months to measure 10 samples, because to measure a crystal properly, like you have to because it ages and it burns in and all these things happen to it. And then when we got it in here and we're listening to it and we're just like, wow, this is good. We like this. So that's another part of the QX-5 that, you know, it's like, again, all these little pieces
Yeah.
that like over time, like you just keep building up bit by bit by bit, where, you know, the story started out, oh, I was riding my bike 10 years ago and saw this lab and I said, what's this lab about? It said like Timing Solutions Limited or something like that. And I'm like, I wonder what this guy does. And I knock on the door and, you know, he hands me his paper and his business card and he's really nice, you know.
Well, it's like solutions to problems we didn't know existed.
Yeah, yeah. And then you just kind of file that away and you go, okay, like I know I'll need this someday. You know, because the thing is like it's too expensive. I couldn't put it in a Pono player. You know, it's just way too expensive. But we're able to like bring now, it's like I said, instead of having this is a performance equivalent to any clock on the market. I won't say it's better than the best clock on the market, but it's as good as any clock on the market. And it's built right in there. And it's right there, and you don't have to have any cables, you don't need the oven, you don't need all that stuff, and it's like, it's nice, it's good.
Well, I'll just, yeah.
Okay.
Oh, we're rolling?
Yeah.
Okay.